Alright, so now what we're going to do is combine all three of our measures of central tendency, the mean, median, and mode, in a single problem. And we're going to start looking at this and saying which one of those three things, the mean, median, or mode, represents the most central of this data and perhaps why. Okay, so it says for professional sports teams, the salaries of a few very high players can lead large differences between the mean and the median salary. So two measures of central tendency that are very, very different. In 2015, the median MLB, Major League Baseball salary was about $1.65 million. The mean salary was $4.2 million. So if they're both measures of central tendency, which one was more accurate? Were most people making about 1.65 million, or were most people making the mean, which was about 4.2 million? It says the mean, median, and mode are all averages. The mean, the median, and the mode are all averages. However, they are generally not equal. The mean of a set of data is the most sensitive of the averages. So again, remember, we typically use the mean, and it is the most sensitive. So it says a change in any of the number changes the mean, and a mean can only be changed drastically by changing an extreme value. It says in contrast, the median and the mode of the set of a data are usually not changed by changing an extreme value. If you have one test score that's really low, like a 30, and it drops down to a 10%, that's not going to change the median or the mode, but that will drastically change the mean. So anytime you have those extreme values, those outliers, your mean is very inaccurate. Okay? So it says when a data set has one or more extreme values that are very different from the majority of data values, the mean will not necessarily be a good indicator of an average value. So let's look at some examples that kind of emphasize that point. It says find the mean, median, mode for the salaries of 5 employees of a small company. So the first person makes $370,000, a $60,000 employee, $36,000, $20,000, $20,000. So what I'm looking at here, I'm thinking of a nice small business where the owner probably makes the $370,000, the manager probably makes the $60,000, and then the other employees make the $36,000, $20,000, and the $20,000. So maybe it's a full-time employee and 2 part-time employees or something along those lines. So the question becomes, if they had to report their average salary, if someone was talking about what's the average salary, we're going to get very different points of view here. If you're the owner, you're probably going to report one, versus if you're an employee, you're probably going to report another. So let's go ahead and calculate the mean, median, and mode for these data sets. First thing I want to do, I'm going to do the mode first. Why? Just because mode's usually the easiest. Just looking at these numbers, I see that 20,000 happens twice, so I can immediately go to the mode of this data set is $20,000. The median of this data set is probably what I'm going to do next, because the median is just find the middle. It's already organized for us, so I'm going to do the same thing. I'm going to slice off the ends. I have 370 gone, 20,000 gone, 60,000 gone, 20,000 gone. So the middle of the data set, which is the median, is $36,000. Okay, now let's look at the last one. Let's go for the mean. To find the mean, again, what I have to do is add them up. So I have 370,000 plus 60,000 plus 36,000 plus 20,000 plus 20,000. That was 5 employees, so I'll divide that by 5. And I'm getting a mean salary of, punching it into my calculator, I'm getting $101,200. So there's the mean, median, and mode. All of those are measures of central tendency. But again, big picture, ask yourself which one of these represents like the middle ground where most people are at. So if you ask the boss, most likely the boss, the owner, I should say, would say that the average salary is $101,000. That's quite humorous here to me, because not a single employee makes near that amount of money other than the owner himself. But if that owner was representing that company and they're writing up, oh, come work for me, the average salary is, they would write the $101,000, because that is an average salary. But if you ask the employees, what does the average employee here make, you're probably going to get something closer to the $20,000 to $36,000 range, because that's where most employees are at. In fact, over half the employees are between $20,000 and $36,000. So it depends on perspective, and it depends on what you're thinking about. What is the average of something? Well, the average can be greatly skewed. Why is this so skewed? Why in particular is this mean so off? Well, if you look at the data sets, that $370,000 is nowhere near any of the other values. That $370,000 is called the outlier. And when you have an outlier, your mean does not represent the middle of the data whatsoever. So in this case, I would say the mean is a horrible representative of what it is. Let's look at example 8 here now. It just says, suppose you average 60 miles per hour on a one-way trip of 60 miles. On a return trip, you average 30 miles per hour. What was your average speed for the trip? And then it says, hint, average rate equals total distance divided by total time. Okay, so let's think about this. It says, suppose you average 60 miles per hour on a one-way trip of 60 miles. On the return trip, you average 30 miles per hour. So what was the average rate of speed? So to find that average rate, what we need to do is the total distance traveled. Well, let's think about the distance. One way it was 60, and then we did a return trip. So that would be another 60. So it seems to me that my total distance had to be 120 miles. Now we need the amount of time. Well, think about going there. If we were going there, it was 60 miles at 60 miles per hour. So if I do my conversions like I earned earlier, I start off with 60 miles, the distance, and I was traveling 60 miles in 1 hour. I can cross out my miles, and I would end up with a total of 1 hour. So how long did it take me to get there? It took 1 hour to get there. Well, let's think about that return trip. That return trip, I still have to go those 60 miles, but I was traveling at a different rate of speed. I was traveling at 30 miles per 1 hour. So if I do 60 divided by 30, that tells me that it took 2 hours to get back. So if it took me 1 hour to get there and 2 hours to get back, that's a total of 3 hours of travel. Again, 1 hour to get there, 2 hours to get back. So what was my average rate of speed? Well, 120 divided by 3 would be an average of 40 miles per hour. 40 miles per hour, you could put mph on this one, would have worked just as well. So there's your average speed.